Okay. And I just rejected. Yeah.
Of course, half blind, Jeremy.
Yeah.
Basically. Yeah. No, I didn't. I'm lazy. It's almost and so I think I'm
I know.
right before these like violence.
Leave that there.
Did you see the eclipse? Get to see the where'd you go? What? Did you see the eclipse? Where did you go?
I went up to Guinan, went to part of Guinan. My daughter had a condo in Maine.
Sure.
So we were able to go across.
Did you see the latest update from Bill? He said
I was gonna go north, but I wanted to go across.
the 90 campers was taken.
Yes. Yeah.
They said he was. Be here.
Yeah, okay, great, thanks. That's, I kind of knew that, but I'm glad you sent me.
I saw it was cloudy or maybe cloudy and I had two tickets. I don't know what was saying.
I thought we had friends that went to taxi because they were going.
Hello, everybody.
Hello.
Welcome to the April meeting of DVAA. Brian? Brian? Can I get you to turn the lights down just so you can see the slide? Since we're going to be seeing so many great eclipse photos next month, I decided I'd start with this very cool photo that we got from the cloudy Texas skies. Whoops. There it is. Got it. Yeah, it's working.
Okay.
My son-in-law took this photo and I just thought it's very cool with the colors of the clouds that are backlit by the eclipse. Who would have thunk it? Where did everybody go? Well, these are the people that announced on groups.io where they went. Look, we were all over the place, all over the path. And I think that there probably are a lot of people missing from this list, but we got every spot from, doing the wrong thing here. From Texas to all the way up to Canada. So we're looking forward to hearing everyone's experiences next week. I'm sure Jeremy will, or next month, sorry. I'm sure Jeremy will tell you all about it, but next month we're having members night and it's going to be all about the eclipse, where you were and what you saw and photos and your stories. So looking forward to that. So what's coming up? We have the spring field trip at Cherry Springs. We're really hoping for good weather. We have 3 nights reserved. So basically there are 3 nights in 2 lodges at a lovely field that is just about half a mile from Cherry Springs Park. And although the rooms are taken, but there's a dorm style place with 5 beds in one of the lounges. So if you don't, one of the lodges. So if you don't mind sleeping in a dorm style space, we still have 5 beds that are available. And you can also camp on the field if you want to. So even though it says currently full, that's not quite true. So if you'd like to know what the situation is, send an email to Bill McGeaney or camping@dvaa.org, and he'll tell you what the scoop is. Second thing I wanted to highlight is the astrophotography workshop, May 15th on Zoom, open to everybody. And I'll have Lou come up and talk about that a little more in a minute. Of course, we have our general meeting next month, May 17th. That's here. And that's, as I said, member night to present about your stories about the eclipse, viewing the eclipse. Our start party next month is May 18th with a backup date of the 19th at Valley Forge. And we have been having great turnout with more than a dozen scopes and lots of the people from the public. So I invite any of you to join us if you haven't already. It's been working out really great this year. On June 1st, we have something called the Great American Backyard Campout. So this is an event that many different communities have. And we like to support Radnor, especially at their event. So what it is a bunch of families, scouting groups, and so on, go to the park called the Willows Park, and they teach them camping skills, and they have a campfire. And then far away from the campfire, we set up some telescopes and let them look at the night sky. So we can use a few people, telescope operators needed for that. So if you would like to join us, please let me know. That's June 1st with the backup date of the 15th. And it's a pretty short night. I think it's only maybe an hour and a half of the time when we're set up, but lots of families and lots of fun kids. So it's usually a great event. And on June 21st, which also happens to be the night of our regular monthly meeting, but the folks at Green Lane want to have a hike on the night of the full moon, and they want to end the hike with looking at the full moon through a telescope. So we actually need a couple of volunteers for that on June 21st out at Green Lane. Okay, I'd like to emphasize to everybody that our classified ads module is now up and running. And people have been adding things for sale. And we have 1, 2, 3, 4, 5, 6, 7 things on the list right now. So it'd be great if you check it out and see if there's anything you like. The prices are great. We have, the way to get to it is go to the website and check out the classified ads button.
You have to be logged in for that.
You do. You have to be logged in. Yes. Check out the classified ads button and you'll see multiple things listed. And if you click on the view more arrow, you'll see the description of who's presenting it for sale, condition, the price, how you pay for it, where it's located, and all that kind of stuff. Now, there are actually 2 types of listings here. One is for members to list items that other members can buy. And that's an example here where Al has this solar filter that he's offering. And then another way where we are acquiring items to list is if people have donated them to the club. And in that case, the proceeds will go to DVAA. And so we need a check or credit card via Club Express for those items. And the items will be explained. Tonight, we have 2 of those items from the classifieds here for you to take a look at. You can buy them tonight if you're interested. There's the Celestron power tank and also a Barlow that is let's see, Mead Series apochromatic Barlow 1.25 inches offered by Barry Johnson. So I encourage everybody to take a look. Once we are sure this is working for members, we will then open it up to non-members to buy. But right now, we want to make sure it's working okay. So it's just for members to buy or sell. Okay, now we have chair reports. Brian, you can turn the lights on before you come, please. Sorry, I just wanted to do that photo justice.
We have 6 new members this month, and I know at least 2 of them are here because I gave them name tags tonight. John Griffiths, Selena Foran, Prentice Hall, James Wright, Desiree Vanneman, and Wesley Vanneman. I know that Selena and John are here, so Mike, if you're welcome.
Welcome to you. Is anyone here for the first time tonight? Oh, welcome to you also. Okay, now, as I was walking in here, a bunch of people came up to me and said, I want to talk tonight. So if I forget to call on you, remind me, okay? First, we're going to hear about astrophotography from Lou.
Hello, I'm Lou Barbaresi. I'm the astrophotography chair. Just
You want to stand in front of the camera?
reminding everybody that there I am. Hello. Just reminding everybody that we have a monthly meeting that's held 2 days prior to this meeting on Wednesday. So we just had our meeting this Wednesday. We have it's open to everybody, beginners or advanced. If you're interested in astrophotography, you don't know anything about it, you can just come and join, and we'll help you along so you don't get you off on the right foot. You don't spend money on things you don't need, and really you don't need much to get started. I mean, just a DSLR camera and a lens and a tripod. And on that note, in June we're going to have a guest speaker, Andrew Hitchner, who's a member here, explain to us his techniques on how he does wide field landscape astrophotography. He's got some beautiful images that anybody can do with just a regular camera. So I encourage anyone that's interested to join in. All you have to do is look at the calendar, and it's just we usually put the hyperlink on the date. You can just click and it's a Zoom meeting. So anybody who's interested, please, join whenever it's convenient for you, and we're happy to assist you.
Thank you. Ken, did you want to say anything about the raffle, about any explanation necessary?
Yes. Okay. Our raffle tonight, I made a little bit of a mistake and didn't bring the tickets, so we're gonna do this.
I won.
Jeremy won all the books. I think we'll do it as a book sale. So if you see a book over there that you're just itching to read, and there's some really interesting, some of those old books are really kind of interesting. I've been glancing at them myself. If you want to make a donation and pick up a book, I think that's a good way to go. So there's some, don't judge a book by its cover. Some of those have some really interesting facts and thanks.
Thank you, Ken. We also, over there on the wall there, we have a Galileo scoop that was donated to DVAA, and it is free for anyone who would like to take any part of it or the whole thing. So take a look, see if it has your name on it. Okay, now I'd like to introduce Al, who has some awards to hand out. Alan Purdy.
Outreach is a very big component of the DVA, almost to the point of it should be its middle name, along with astro imaging and that kind of thing. And outreach involves a lot of people, a lot of volunteers, And we like to acknowledge that every year, if not more than that. The DVA belongs to the Night Sky Network, which is funded by NASA, and they encourage outreach. They give us toolkits and every year they give us a small number of pins and downloadable certificates to give out to those people who have helped out at our outreach programs. We don't have enough for everybody, but over the course of a few years, we'll hit everybody. So this year, I'd like to give out 4 certificates and 4 pins. 3 of the 4 people are here tonight, so that's great. So in alphabetical order, Barry Johnson, Ken, Tom Nolasco, and Stan Williams. I'm going to give it to you at the next event if you're looking. So come on up and get the certificates, and I'll give you the pin. Now do this. Okay, Barry, there you go, huh? You want a telescope one? Huh?
Sounds fun.
Okay.
Get in front of the computer so they can see you online.
Huh?
Yeah, go. Where the camera is.
Is my toupee on straight?
Jen, you want
Okay.
to stand over here?
And Ken,
I'm in it
come on
all
up
the time.
and see yourself in the
Yeah.
wall.
How about Al?
No, wait for Ken.
I can wait.
I can't do it. You're in the clips, Ken. Absolutely.
Thank you very much, Al, for making this happen. And thank you for all the 3 of you. I mean, I know a lot of you do a lot for the club, the 3 of you. And this is a recognition for outreach, but also many other things that you do for the club. So thank you very much. Okay, I have a couple of other small announcements. First is that remember that May 1st is the deadline for submission of junior of the youth awards for DVAA Youth Awards. So if you'd like to know anything more about it, there's a box on the website you can click, but May 1st is the deadline to submit any research projects that you might, that high school students and younger might have done during the year. So that will be coming up soon. And finally, you might remember we had an election that last December, and we added the option to have a youth member as part of a non-voting member of the board of DVAA. And so we now have an application and a job description for any of you that are interested. If you are between the ages of 14 and 17, or you have someone who is, and you are a DVAA member, you can check out the qualifications in the email that was distributed. If anyone needs another copy of that, let me know. And we'd like to have the applications in by the 15th of May. Okay. All righty. Now I'm very happy to introduce our observing presenter, Sylvie Stonberg. Would you like this?
Should I just hold this one?
Well, then you, if you want to be hands-free.
Yeah, I kind of. I just clip this to my cord again.
Yeah, I don't think it can be. Do you have a popper? What if
Is my phone working? Check.
try to get on camera?
Technical difficulties. All right, does the microphone work?
Oh, we do not turn on.
Is it working now?
Yes.
Ha. Well, hello, everybody. My name is Sylvie Stonberg, and today I'm going to be telling you guys about the flare star T Coronae Borealis and how you can see it. This star is incredible, not just in the sense that it is going to multiply its brightness by a way that we haven't seen in ages, but the fact that you're going to be able to see it this year, potentially even tonight. Now, the first thing we need to understand in order to really wrap our heads around T Coronae Borealis is the type of star it is, which is a nova star, or more specifically, a recurrent nova. A nova star is a binary star, which is composed of one white dwarf, which is a dead star, and one living star, which is usually a main sequence star, which is what our sun is, or a red giant, which is a very old star nearing the end of its life. Now, these stars enter a very tight orbit with each other, which causes the white dwarf to start accreting the larger star's mass, and therefore creating some sort of an atmosphere around itself. Eventually, when the white dwarf has collected enough of the other star's mass and the atmosphere heats up to a critical point, the atmosphere will violently be expelled from the white dwarf, causing an absolutely massive flare in the sky. When this happens, it's called a nova. And then it just happens in a cycle again and again and again. To make it more familiar, we can compare it to a water balloon as seen in this picture right here. In order to make the kinematics more familiar, we can imagine that the accretion disk is a bit like a water balloon. It will fill up with more and more and more water over time until it eventually reaches a critical mass and heat and gets violently expelled. The only difference is that unlike water balloons, this happens again and again and again for a very long time. I promise I will clean that up after my presentation. These will go in a consistent cycle until the red giant star is eventually gone. So T Coronae Borealis is an incredibly special nova star. Despite being located 2,600 light years away, it's going to be extremely bright. And it only flares up like this once every 80 years or so. So if you don't see it now, most likely you will never get to see it. And using the stellar magnitude system, when T Coronae Borealis gets brighter, it will be 1,500 times brighter than it usually would be. But don't just take my words for it. Whether you're watching at home or in the in-person audience, what I want everyone in the audience to do is take out your phone and turn on the flashlight. Once everyone has done that, I want you to look around and just see how bright a phone flashlight is. To put into perspective how much brighter T Coronae Borealis will be when it flares up. Normally, T Coronae Borealis would be the same brightness as 2 phone flashlights, but when it flares up, it is the same brightness as the brightest flashlight in the world, which, for context, can light up 20 soccer fields. 20. That's how much brighter the star will get to the naked eye in just a span of a few minutes. Incredible. It's incredible. And just for context as to how bright the star will be, it will be the same brightness as the North Star, Polaris, to our naked eye. Just to put that into perspective, that on the top is a picture of T Coronae Borealis I took, and below it is a picture of the star Hamal Alpha Auritus. This star is around the same brightness as Polaris and how bright T Coronae Borealis will be to us. So how can you see it? Well, sadly, we don't know when it will nova, but we do know that it will go out anytime between now and September of 2024. Since Coronae Borealis is a northern constellation, you don't actually have to travel in order to see it since it's pretty high up, hence the name. So that if you do want to travel, I'd highly recommend going up instead of down. However, you can judge that based on your coordinates, but most likely won't need to travel since it's more than bright enough to see by the naked eye. But how do you find it exactly? That's what I'm going to tell you. Arc to Arcturus don't spike to Spica. I repeat, Arc to Arcturus do not spike to Spica. That is the worst thing you could do. When you see Arcturus, when you arc to Arcturus, you instead need to look for the bright star Alphecca in Coronae Borealis. And when you find that, T Coronae Borealis will be directly next to it and around the same brightness as it, if not brighter, which it most likely will be. It'll be right to the left of Alphega, and it'll be easy to find since they are very close to each other in the sky. If you want to know exactly where T Coronae Borealis is, it's right next to Epsilon Coronae Borealis and very close to Alphega. But for those of you who really want to know where it is, here's the coordinates, and I'll be taking questions. Please, if you want to write down the coordinates, do that. Thank you. Does anyone have a question? Yeah.
How long will the flare be when it flares? And will it be one time between now and September?
Yes, it will only be one time and it will remain at its max brightness for a good 3 days before dimming down again.
It's gonna be cloudy those 3 days.
Probably. If it was cloudy during the eclipse, it'll be cloudy during the nova. Rule of astronomy. Ha, lucky. All right. Well, thank you guys so much for listening.
Hopefully it won't be tonight because we're all in here. Okay, now I'd like to introduce our program chair, Jeremy Carlo, to introduce our speaker for the tonight.
All right, thanks, Jen. First, a couple quick things. For those who don't know, the South Jersey Star Party will be next weekend. That's May 2 to 5, whatever that is. So if anybody's interested in getting out to a reasonable dark sky site, that'll be the next opportunity to do so. Also planning to go up to Cherry Springs, but it is May, so you got to hedge your bets. And hopefully one of those weekends will have a clear night in it, maybe 50% chance. We'll see. All right, so as far as programs go, as Jan said, next month, May 17th, we're going to have a member night on the eclipse. So fortunately, it seems like a lot of people got to see the eclipse, so I'm expecting we'll have a lot of people signing up. Hopefully we'll have some nice short presentations, maybe like 5-10 minutes, maybe 15 minutes, and we'll have a whole bunch of people coming up, show some of your best pictures, any interesting stories, interesting stuff that happened along the way, traffic jams, interesting people, jail sentences, whatever, whatever interesting stuff happened while you were out to see the eclipse. Hopefully that'll be an interesting meeting. Yeah, Mitch.
On eclipse day, I literally saw 2 times a black dog walking backwards.
Black dog walking backwards. All right, we'll hear about it next month. In June, we're going to have one of our returning champions. We'll have Ray Harris from LVAS. He's going to be telling us about the lost constellations. Looking ahead a little bit, in September, we're going to have another outdoor meeting at Fort Washington State Park. We've done that the last couple of years. That's been quite successful. A few other things in the pipeline. We're hoping to get someone from the web operations team who's going to tell us about essentially how they operate the Webb telescope, how they communicate with it 1.5 million miles away, how they schedule observations. So what do we look at and when do we look at it? Because they don't really have day and night in the same way up there. But you do have to deal with a lot of other issues with the Earth going around the sun and which areas of the sky are accessible and how quickly you can move from one place to another. So we'll hear about that. And I'm also hoping to get somebody from the Voyager team to tell us about what's going on with the Voyager. That's been out there 47 years, so I think its AARP card is on the way. So that's about what we're planning for now. But tonight it gives me a great pleasure to introduce Ed Guinan. Ed is an institution at Villanova University. I won't say how many years you've been there, but he started as an undergrad. So that goes quite a few years back, maybe even before Voyager. Yes, even before Voyager. So basically anything you can think of in astronomy, Ed has been involved in it in one way or another, whether it's planetary observations, whether it's stellar observations. He's been on a number of different NASA committees for funding of space missions. He was also elected a legacy fellow of the American Astronomical Society a couple of years back. He did present to us a few years ago about Betelgeuse, another star that's gone through some instability, which thankfully it's still there. Because if that does go supernova, you can say goodbye to any dark sky observing for a good couple of weeks, maybe a month or more. That's going to be about as bright as the moon. But anyway, Ed is here tonight to talk about one of his other projects going on, which is the Mars Gardens and the idea of farming and gardening on Mars. So please join me in welcoming Ed Guinan. Let's get your let's get your tone queued up here. Okay.
That's my phone. I thought.
You want to go get it?
Well, no, I still like turn it off.
Good background music.
I have show and tell.
Oh, I think I forgot to turn it off.
Oh, yeah. And it's up here. You just slide it.
Yeah.
Is that it? Give up. Maybe. No, it's it. It's all right. It's in my jacket and.
Might be a little distracting if this person doesn't want to go back.
Maybe it's a notification that T just went off.
I turned here. I don't know. Oh, it's done. Okay. It's not so called. What do you want me to? Clicker.
Wasn't it there?
Oh, but maybe I put something on top of it. Clicker is gone.
Is it up on the shelf over there?
Oh, I do. Let me just see.
Here it is.
Let me just see what I have here.
Oh, that's my
What is your stuff?
It's in a pickpocket here.
Take Jeremy's lunch.
Yeah.
Stuff. Okay. All right. Nice to be here. I was here virtually a couple of years ago during COVID when Betelgeuse was misbehaving, and we gave a talk that way. This is a completely different deal. This is a project that we started in 2017 about trying to grow plants in Martian soil. It involved students in my astrobiology course, and it's still going on. We're still experimenting and trying to do this, if I have it right. And so we use Martian simulant soil, which I have here, which I can pass around. And if you want to pay, I don't know. It's dusty. Don't put you'll make a mess. You can open it up. So what we'll do is just take you through. Jeremy said this goes backwards, and it does. Talking points real fast. The motivation is that we're planning to go to Mars. So to have humans off Earth. The moon first, it's been delayed. Artemis project has been delayed maybe 2 years. Then what's Mars environmental conditions? Is there, it's cold, as you know, and is there water there is a big question. There probably is. And then we're growing plants in space. That's where I got the first idea of this, because NASA called me about possibility of the, well, I was on a committee that was evaluating the space mission and growing veggies in space. And then I decided, well, we should try that on Mars. Red Thumbs is the project's name. Villanova, it's funded privately and some funds from NASA. Outcomes, we'll talk about that, winners and losers. Some plants do well, some don't. And then some examples, like, as you can see, I'm showing the ones that do well. Dandelions. Undergraduates were very interested in, beer. So and also marijuana, but we didn't go there. So we tried to grow hops, and we did. And I brought some along in case you want to try it. Just hops are crazy. They take over your garden. And so we'll talk about that quickly. And also to make a closed system where you have Martian worms, but actually just plain old worms, and we use them as their droppings as fertilizer. So that makes, instead of using chemical fertilizers, we can eventually use worms. So in the next 2 decades, NASA and SpaceX, NASA planning to have program on Mars. SpaceX was supposed to be there now, I don't know if they'll ever get there. Send human missions to Mars with the ultimate aim of establishing a permanent, you don't call it colony, it's a presence on the planet. You're not colonizing. So NASA's program is called Journey to Mars, 12 long, and the whole prototype is the moon to check everything out, whether it works, because you can get back from the moon pretty fast. In Mars, it takes 6 months. So that's why the Artemis, I wanted them to skip the moon and go right to Mars, but it's dangerous. There's a lot of bad things that can happen. So the date is still around 2035 to 2040. And I always, as a kid, I always wanted, Mars was one of my special planets and all the science fiction involving Mars. So it was one of the things I never thought I'd ever be working on anything related to it. And it's just that came up that I was able, I'm a farmer, I'm a gardener, and then I put together we have a greenhouse, I've put together that and made up the program. Oh, I pressed the wrong one, I think now. There we go. So the motivation, you know what I'm doing? Where is the little clicker? There we go. So there's the Artemis program. And we'll just keep going. So this is about 26, I think, is the recent guess. I was on a panel and it's too dangerous. Some of the rockets that they were going to use failed. So it's not, in manned missions, you have to be, 98% pretty sure that you won't kill people. And that it's not there yet. I wouldn't fly on that rocket yet. The Artemis mission I thought is still dangerous. And Mars is worse, so you have, because you're going further away, and 10 years later, it's coming along. The rocket it's a new rocket and a very large rocket. And so they're still working on that. So SpaceX mission to Mars, Elon Musk, it's not going to happen until 26 or 27, if that. I don't even know if that is right. I met Elon Musk about 10 years ago, and he invited me to join him in SpaceX. And I'd rather stay at Villanova, but I know him. And he's a strange guy, as you could tell. So the Mars missions, what the idea is, why go there? And one of the reasons is making humankind a multi-planet species in case some disaster happened on Earth, like global warming or an asteroid hits. Human beings would have, or a plague or zombies. We would have human beings species would still be around. And you saw the movie Martian, and where he was, Matt Damon or Mark Watney was left behind. He survived by growing potatoes, which they had there, in human feces and in Martian soil. Martian soil does not have much nutrients in it. It's just like sand. It's iron oxide, silicates. There's not much you can do with that. With how the potatoes grew was because of the human feces. Instead of human feces, we use worm feces. So it makes a much cleaner operation. That's the space station program. They've been doing it for 7 years, and now they're eating some of the plants. They had to bring them back. Now they can eat half of what they grow. And they grow them under LEDs, lettuce, kale, things like that, grow very well in space, as he's showing there. But they're growing with, under nice conditions. Humidity is regulated in the LEDs. On Mars, it's not going to be like that. The Martian surface is really cold, 40 degrees, minus 50 degrees, no atmosphere, etc. So you have to make environments for them. This I'm painting. So this is a experiment that they've been carrying out. That's kale. The students do not like kale, even though it's one of the most nutritious veggies going. I don't like it all myself, but I say they like, they pick things like one of them wanted to grow roses. Well, what's that going to do? How are you going to eat the petals? So the students were kind of thinking, I said, here on Mars, you're the agriculturist. These people need food. And then you're thinking of a rose bush. So So this is the specs on Mars. The average temperature is, it does go up to 60 degrees Fahrenheit in the summertime, in the daytime. That same evening will be minus 50. So the average temperature is very low because it's cold. It's further away from the Earth. Has a thin atmosphere. Its atmosphere is 0.6% of the Earth's. So it's virtually does not exist. Our chemical composition is a CO2. And there nitrogen radius is half the Earth size, and so the gravity is 38%. That's nice when you're building things at your gravity's low. You don't need strong structures. Moon is better. There's no wind and there's the structures. You have 1/6 gravity. The length of the day is similar to ours, 24 days. It has seasons. Its axis is still almost the same as ours, although it's unstable. Earth's axis is fixed between 22 and 25 because of the moon. These have moons that are captured asteroids, which do nothing. So it can have very large ranges in climate over hundreds of thousands of years, and does. The other of the year is almost 2 years, and there's your ambient solar radiation. This is what counts, 43%. And that's because one over the square root of this is. So it has no ozone layer. So what happens is that UV will reach the ground, which isn't good. X-rays are blocked, fortunately, but cosmic rays are not. So the surface of Mars is pretty hostile. It won't hurt the plants any, but it will hurt people. So when you're out, you're in an environment where you don't want to be above the surface very much. This is a picture of the other element that you have to worry about is dust storms. This is not a dust storm. This shows the setting sun and how the sky looks. This is real color, but they do have there's dust in the air, very fine dust with that bottle that's of the Martian soil that's going around. It's very fine, so it doesn't take much to cause it to blow up. And this shows the sun setting on a clear day, clear night. So what's the background? My background on this is that 20 years ago, I was involved in a paper to study what happened to Mars. Mars has evidence, as you'll see, evidence of water, oceans, rivers, and all that. And it had a temperature, but it's very similar to the Earth. So 4 billion years ago, 3.5 billion years ago, Earth and Mars were similar in terms of their climate, oceans and so on. But what happened on Mars is that it became, as the picture you see on the right, Mars lost its water and lost a lot of its original atmosphere. And the paper I was involved using the data we had for the early sun and putting it into model atmosphere. So this is what Mars may have looked like 3.8 billion years ago. Oceans covering somewhere between 20 to 40% of the surface. It's all gone away. And what caused it to go away was the study that we made. It's not all gone away. So we had a paper in Icarus called Loss of Water from Mars. And we used a model atmosphere like Earth had, and we irradiated it with the wind of the sun and the UV radiation that the sun had at that time. The sun was more active then. Earth survived this, but Mars didn't. And what happened with Mars is why the ocean left. Mars is a smaller planet. It's 1/10 the size of the Earth. And what protected the Earth atmosphere was the magnetic field, magnetosphere. And that's caused by Earth having a liquid iron core causing a magnetic field. Mars had one too. But Mars is a little planet, so it lost heat more rapidly. And about 1 billion years in, the liquid iron core solidified, no more magnetic protection, and the solar wind began to encroach into the atmosphere, stripping water, breaking water. Ultraviolets broke the water molecule up, and it got dragged off into space. This is what our paper was about. We predicted that about 80 to 85% of the water was removed, so there is a little bit left. And during that time, the Earth cooled down. So this is like Mars was. This is like the Earth is now. This is how Mars was. It had a magnetosphere. It was protected. the solar wind was mostly going around. And what happened is that the core of Mars, because it's a smaller planet, cooled down, no magnetic field. And then the solar wind began to encroach ultraviolet and X-rays broke up the water molecules and it just blew the atmosphere off over hundreds of thousands of years though. And that cooled the planet down. Water was one of the major greenhouse gases. It is on Earth. So number one greenhouse gas on Earth is water vapor. On Mars, it was the same way. So as it lost the water vapor, it cooled down. Fortunately, fast enough that not all the water left. So it froze out before it completely lost water. Venus lost all of its water because it was closer to the sun. And so this is the process that takes place. The sun is much further away. You have the incoming X-ray UV radiation. And what happens to it is, just making this up, you have water molecules H2O, which is dissociated into H's and O's. The H's get blown off, carried away by the wind. It's happening even now. Mars is still losing atmosphere, but not much. There's a satellite called MAVEN that's orbiting to check that. What happens is that the hydrogen is a lighter element, so it's easier for it to escape. So in our paper, we had 80% of the oxygen was actually left behind. It's heavier. And we think that the soil on Mars, the red soil, the soil I'm passing around, which is full of iron, was the oxygen that was stripped off the water molecule. So the process took place. Mars really didn't have a chance in long term because of how small it is. Its gravity is less. It had a good time for about 500 million years. It really, a planet that size would have trouble retaining its atmosphere because of the iron core, liquid iron core the hot liquid iron core would cool off fast. So when you find a planet about half the size of the Earth, when you see exoplanets, you're starting to wonder whether that planet would have an atmosphere or not. Evidence of Mars is these kind of things, the runoff, these features you see on Mars that are around for a long time. There's no question that Mars once had oceans and rivers and things like that. I used to have to worry about that. I don't anymore. I guess I'm not facing, okay. I'm not facing the screen. There it goes. The real evidence was this. In the NASA archives. Well, Jeremy, why doesn't this see, where does the active part?
Should be RF, it's Bluetooth.
Okay.
It's not,
This is
not
not,
responding.
no, it isn't now. There's so much evidence. This is shale kind of mudstones that you find on Earth. This is what you find on Mars. All evidence of past water, lakes, probably salty. So its oceans may be covered. If you spread them all around Mars, would be about 100 meters. They didn't do that because it went into the deeper parts of Mars. So, okay, Bluetooth, go. I'm pressing the right button, but maybe I'm pressing the wrong button. I'm one up. I see what's happening. So there's other missions that go there that found, this mission is Odyssey mission, NASA and European Space Agency, that the blue parts are where you find strong indications of H2O, or you find protons. It's going to be water or ice. And the part there, of course, around the poles, CO2 and water are both up there. The part that's most interesting to NASA is these areas, because you don't want to be in the polar areas. There are crevasses and things like that. So these areas in here and here are the targets for the missions where there is evidence of underground water. I am pressing the right thing. There we go. And you can see things like that. When they orbit, when they analyze this, you see mostly the South Pole. Liquid water was discovered under this in lakes under the South Pole. Then you see exposed ice. These are called scarps. That blue part there is ice that's exposed. So there's ice there, and it's water ice. There's plenty of dry ice, but there's actually a lot of water ice. And then you see, we think there's about 13% of the original water is still there in the form of in the ice caps, mostly in the ice caps. And so going on with the background, this is the goals of our program. So it's mostly educational based, because we have an astrobiology course at Villanova. And as a project to liven it up in 2017, I introduced a lab, and the lab was trying to grow plants in Martian simulated soil, which you can buy. It's for sale. So we bought it, and I have pounds of it. And the second part was to try to see what does grow there. This is what NASA was interested in, what plants do well. Now, again, you have to have a greenhouse. We used Villanova's greenhouse, and the temperature in there is about 68 degrees. So it means on Mars, you have to have a greenhouse too. And we tried to run it. We reduced the light to be about 43%, 45% of what you normally get on Earth to simulate the light conditions. It's tough because this meant a lot of plants like tomatoes need a full sun. So we kind of were looking for plants that would do well in partial shade to kind of give an idea. Then we ended up using LEDs to supplement. So the plants are grown, would have to be grown. They can't grow on the surface. There's nothing is sterile, so nothing will grow there. A lot of people think you can have plants growing on the surface of Mars. It's impossible. So how do you know what the Martian soil is? It's because NASA Curiosity drilled in, previous probes too, drilled into the soil and took samples and determined the chemical composition. It is variable. It isn't like on Earth. It depends where you drill. And they only tested 3 places. So you have an idea of what right away, orange, you're going to be dealing with rust, it's iron oxides. So they have a pretty good idea what the Martian regolith is like. And there's so the best match to that on Earth is Mojave Desert. And NASA took Mojave Desert regolith or soil and mixed it with chemicals or minerals to bring it up to very close to match Mars, 93%, 95% of what you get on Mars. So that was good enough for us, and stuff looks like that. And I'm passing it around. It is another, if you want to see the more granular stuff, this is easier to deal with because it isn't a fine dust. We grow things in that stuff. And I have brought with me some extra if you want to try to take it home and grow. And I also have something else. I also have lunar soil, simulated lunar soil, and I have a piece of Martian, a meteorite from Mars. And I also have, for those who are old enough, I have, what do I have in there? God, what did I pull up? I have hops. So if you want to make some beer, I don't recommend it. It took over the greenhouse. I mean, the hops is a weed, and we had to destroy it. We did make beer, but very bad beer. But we have, if you want to grow hops in your garden, I brought some along. It does grow in Martian soil, because it doesn't care. It's a weed. So the difference between, so we use Mojave Desert, which is an iron-rich lava soil, and mix it in with other minerals. You can bring it right up very close to what you get on Mars. That's what we did. And that just shows the company that makes it, Martian Gardens, which I stole the name from almost. And these are the first group of students that tried it. So this is their experiment. These are juniors and seniors. I'm in there somewhere, yeah, Scott Angle, and there's some of the plants growing. So they were able to choose, they had teams, and they chose, some chose wisely, some didn't. And they would have, when you do these experiments, you have to have, you grow stuff in earth soil, potting soil, and then we have different combinations. So potting soil was our standard. We had 3 of each type, and then we had different mixes, Martian soil plus potting soil, Martian soil, worm drop, and various different combinations of the same plants. So these people were doing spinach, carrots, kale, garlic. I kind of was directing them into reasonable plants. rather than rose bushes and things of that sort. I jumped and back one. So let's go this way. Okay. So the students were giving these names, Project Mars Gardens, Team Soil and Greens. So Soil and Green is for the older people would know what that is. It's human. It's human. So I don't know how they knew. These are like 20-year-olds. They were still remember that movie. That's their names. This is another group. So they had to come up with a whole presentation of what they were doing. Operation Martian Gardens, Team Dandelion Brigade, and Hoppin' on Mars. So this group is the one that did beer. And the marijuana group was not here. It's not represented. They wanted to put that in there too. It would grow. And this was the business majors. Help on the slides. Yes, 4 business majors in the class. So we tried a lot of stuff. And this is the seeds. Hops, plant seeds. It's not easy because if you don't water the plant, first of all, the lesson was mainly a lot of the students didn't know plants needed water. So that was a big surprise when their plants died. I said, are you watering them? What? What you need water? It's very surprising how few students know how to garden, how to take care of plants. So if they got nothing else out of it, they learned that you have to water plants. So that's this is growing peas at Villanova. We have Mendel Gregor. His experiments were on growing peas. Peas grew, which I was surprised. They require cool climates, and there was enough light to get them to actually have peas. I thought they wouldn't work. I thought they would just grow and not produce the pea, but they worked. And this is more of dandelions. Turned out to be one of the best. No, it's a weed. So weeds are good to grow because that's why they're called weeds. They're hard to kill. So these are the undergraduate students doing the experiments. And me coming in, watering them because they always forgot. I always found them limp. And if the Martian soil dries out, it turns to clay and a brick. In fact, one of the students, the engineering students, made bricks out of it, and as a way of constructing habitats. So they were great at these are some of the plants that were growing. They were given grades. I was going on a scale of 0 to 10, but the students want letter grades, and so we had a mix of earth potting. And this plant, the spinach noticed the F. This is because the greenhouse went up to 110 degrees. And spinach is a cool plant, and they forgot to water it. So I'm sure it would have done well. This one is earth soil. This is half and half. This is 80% Mars. So you see some do better. Potatoes do not do well normally because the Martian soil is so dense. It doesn't, like a tuber, has trouble growing in it. But onions, garlic, lettuce does very well, grows fast. So one of the best results was dandelions, which are easy to grow and are covering the ground outside. I was going to bring some dandelions in, but you know what they are, because they're a very nutritious plant and doesn't require much care, and they're edible. So I know that people who have suburban gardens hate them. I love them because my grass is pretty bad and the dandelions fill in the bare spots. As you know, if you're a dandelion aficionado, you find these on the web, 16 ways to eat dandelions. And so there's also like dandelion wine, which I don't have. Dandelion tea I did have. You can use the leaves, the sal, you can eat the root. It's a very nutritious plant. So that was like number 1. NASA took this actually. This is one of the plants they might be bringing to Mars because it did well. And as long as you don't pull it up, when you pull it up, the roots aren't there. So you cut the leaves off, you can eat the flowers. When you pull the plant up, that's the end of the dandelion. But it will grow back, as you all know, if you have lawns. So these are, I'm not going to bother you, but they're very nutritious. You can eat every part of the plant. Flowers. In fact, they're perfect now. They're just coming up when they're fresh. You can eat the flower, you can eat the leaves, and even the root. You can make things out of it. And very nutritious, full of vitamins, minerals. And so it was the most successful. And that's actually might be going to Mars. So beating students, well, below the age, well, somewhere over 21, they wanted to experiment with growing hops and barley, and why not? So they, this is the hop plant. See that thing growing up the leaves? It just took over. And I have it at my house. I brought it during COVID. I brought it to my house and dug out part and put Martian, and it's still there. It's growing over the roof of my garage, and I brought it in. I'm just warning you about it. If you want it, you can have it. I just pulled it up because it's basically a weed, and it's a terrible thing to grow on Mars. Why? Because it's all leaves that are the leaves are sticky. You can't eat the leaves, and all you're going for is the little hop flower, which you need to what you want if you want to flavor beer. So, but I let it go. Barley grew, so we had enough to make about a gallon of bad beer. And the kids, the students had more fun, well, going through the process. I never made beer, so I had someone come in to help. So here's the hops and the barley, and you have to ferment it and all that. And they had more fun with making labels. This is the label for Martian Sunset. This, and I couldn't let them have the beer anyway, because I didn't know their ages, but it was, the labels were their thing. So the red lager and stuff like that. So I have the labels and I have some of the bottles left over. That was done 4 years ago. And it does work. A beer company, this was picked up by the New York Times. I gave this paper 2017. I gave a report at the AAS meeting, and I mentioned that you could make beer, and it became a New York Times article. So then it became Martian beer, and I was called by beer companies. And there's cake maker, and it was tempting, except I couldn't make enough. You need large amounts. I just had a little greenhouse. But it could go. They didn't care. They said in the end, even if it had just a little bit of Martian soil, they could call it Martian beer. So I didn't think. I thought it was kind of cheating. And there is Martian beer. There's a place in Colorado that makes it. So the other thing we had in the class for nutritional value was worms. These were garden worms. And used as a food source, also as a fertilizer. So we were using fertilizer. There's no nutrients in the Martian regolith, no bacteria, stuff like that. So we started to use worm poop. So we had the worms, but they're still alive. The worms are, my wife hates them. They're in my cellar now because she moves them around. I had a lot of worms. And so what we did here is why worms on Mars. They're garbage disposal units. They eat garbage. They convert it to waste into compost and growing medium. So the feces of worms which are called trailings. You can buy it at a garden store. It's a fertilizer. It's dried worm feces. It's very nutritious. So it became our fertilizer. So we would gently replace or mix it with the Martian soil to make it like a 50% worm trailings, 50% more. And the plants did wonderful, just like they did on the Martian with its potatoes. We substituted human feces with worm feces. So this was also something that NASA liked because it would be a way of, and on the third thing is that you can eat them. So earthworms are easy to raise and nutritious and a good food source. Extremely rich in proteins and vitamins. So actually, the students in the class who weren't doing well, they could get extra 5 points if they ate the worms. And they did. I ate them too. So, what I eventually got, because I wasn't sure, is that you can buy larvae. I'll pass this around. You can buy larvae of little mealybugs and stuff like
We
that.
need to make some Martian tequila.
Yes, that's a good idea. So we still have the worms are still there. I call them Martian worms, but they're just earthworms. And they're just, I feed them my garbage. We were feeding them the dead plants and sticking in. Some of them had pizza. They like pizza. The students would be eating pizza down there and they would just throw the pizza in with the worms and the worms really loved it. So, maybe that's what's going to happen to the poor people, the people going to Mars. There is a trick I played one year where it's called Jello worms. I didn't have the time to do it, where you use Jello and you put them into straws and you make what's called, they look real. So I would take them out and pull them out in class and ate them. And I got some of the students to, I fooled them. And it's fun to do that. Halloween, I did it on Halloween. So this is how they look. And it's like really rich. That's the soil. The soil there is actually their feces. And they're still going. I don't know if the same worms. And we have a private sponsor here. Elizabeth Madden was a senior student, and an older student that Villanova has, and she donated money for the worm farm. So I named it after her, which she wasn't very happy about. The Elizabeth Madden Martian Worm Farm. So, I never got any more money from her though after that. So the other thing we just tried, I think I skipped one, is that the soil is there's not much in the Martian soil. It's just sand, basically growing things to sand and adding worm feces. So the light is a problem. So we decided to use LEDs, and things grew much better. So this shows one of these things that you can buy a system. So I think what's going to happen is hydroponics, which is much superior to growing things in Martian soil, regolith. I think that's the way they're going to go on the moon, because moon soil is worse. Moon soil kills plants. I have it here. It has high pH, so you have to play with it. Plants will sprout, then they'll die. So this LED with adding nutrients to it is, I think, the way to go. But it's more fun it's more attractive to students to entice them to astrobiology by talking about growing things in Martian simulated soil. So the conclusions are, it's educational mainly, because I've had 4 crops of students, and at least they know the water, plants need water. And we found out that we grew, the easiest things were lettuce, family, and kale, things like that. Scientific results were that you had to, certain plants didn't do well, like potatoes and carrots had trouble because of the Martian soil being so dense. Once we added the worm feces, the soil was more porous and things would grow. The bottom line is that many plants can grow in Martian soil and under Martian reduced light conditions. Hydroponics, though, where you have LEDs, works much better. And we did an experiment recently. We had some surprises. This is Martians came to eat it. So there's a book called Martian Homes and Gardens, actually on the web. And I give that out, and I give a gardening book out, how to garden, when I teach the class now, because they don't know anything. There's very few students that know how even to plant a seed or even to water. So there's, and in Mars, you would have maybe these kind of places where you would have, you don't need the structure because of the lower gravity. And the winds are not so bad on Mars, like in the movie, they exaggerated the effect of the winds. The soil is so, the density of the air is so small, it wouldn't do the damage it did in the Martian. So then you'd have whole systems like this of growing things. Algae is a really good source. So we're doing this now. We have the lunar soil, which is, we'll see it later after it's in this bag. And that's really bad. The lunar soil has a pH of 9. So it's you have to mitigate it, bring the pH down. And this company here is called Exolith. If you want to buy fake lunar soil, you can buy highlands. You can buy the lower lands, the mare areas. So they have different selections where they grind it up and they make it. Since we have lunar rocks, it's really easy to do. We know exactly what it is. So we're trying that last semester, not very successfully though. And thank you I want to acknowledge the Martian Gardens for we got some things at discounted prices. There's a company called Mars Gardens. We got discounts from Exolith, and then we have private sponsors that like Mrs. Madden and another person who actually are funding, and NASA too are funding the place. So ultimately, if you want to see, there's always the question: can you transform Mars into Earth in the future? Ultimately, terraforming Mars. The answer to that is no. Mars lost so much of its atmosphere and water, only 13% is left, that there's really not much chance of bringing it back to reverse the process and terraform. Although you can do it in pockets. And so what you do is you'd have pockets areas where it's warm and there's maybe methane coming up, where there's water underground. But bringing back the planet to what it was is not possible anymore. So there was a study going on about terraforming, and the reason is it lost lost too much of its water. There's still water there, but it lost most of it. This is from a cartoon someone made up on the LA Times about farming on Mars with cats, and cats are ending up making beer. They talk about, they copied my paper and correctly, and then made a cartoon out of it. And the cartoon involved cats eventually making hops and IPA. So it was fun to see it made a cartoon in the LA Times. And I think that's it. Let's see if we get this off. And I have a piece of the Martian. Yeah, there's just this one said, just leave whatever we don't oversaturate it with IPA market. So think of something else. So thank you. What do you need?
Microphone.
Microphone. This is a piece of Mars. This is a Martian meteorite, and which I got from NASA about 8 years ago and have not returned.
It's on the internet now.
I will return it. If you want to look at that, that's a piece that about the size of a finger that's been shaved down. So what you have is a slice that has been, if you want to touch it, take it out, don't drop it. It's very tiny. It's just a slither, a wafer of the meteorite. The meteorite is about the size of your small finger. And so you're actually looking at a piece of Mars. Okay. And anybody want any of this? Anybody want to grow hops? Anybody want to destroy their garden? Okay, I'm ready for questions then.
Okay. So the garden is incredible, but I did want to know that because Mars has such a lower gravity than the gravity on Earth, would terraforming have to, well, not terraforming, because that's not possible, but having a civilization on Mars, would that require just completely regulated environments for humans to live on? Because spending too long in an environment where the gravity is so different just would not be
You have to
possible.
do what people do in space, with no gravity, machines, for lights.
Yeah, it expands.
You even need to do that. It's not as bad as the moon. The moon is 1/6. It stays at 0. So on Mars, you would, so you don't eventually atrophy. They think like if you stay on Mars for about 200 or 300 years, the human body would evolve. If you had generations, they would evolve to a more frail body that doesn't need as muscles. Anybody eat these ones? Right. These are actually good. They're show us. No problems. So yeah, I hope I answered your question. I'll show you. It's not
What do they taste like?
salt. That's the secret. I can't get it open. That is the secret.
I like chicken.
That is the secret to worm cooking garlic salt. Yeah, you can't taste them. These are actually Mexican. Did you get any? Do you want some? Oh, you got some. Nice. Watch. They're good.
I had a question.
Uh,
I know you said there's
Where's the
no,
question coming from?
There
There you go. All right.
you said there's no nutrients in the
Very
soil,
little.
but I do have a question of going way back to the Viking missions and Gil Levin's experiment. He claimed that if you put the radio-labeled nutrients in the soil, that he clearly saw radio-labeled metabolites released. And I don't think I've ever really heard that totally refuted. I mean, is it possible there are spores and things in the soil in there?
Down deep in, maybe, the radiation levels are very high on the surface. So if you go, if you go like 6 inches down, you could be shielded.
I mean, spores.
And that's what they did. They did.
Spores can survive almost anything, right?
Yeah. I have a stuck in my throat now.
I need a beer.
I forgot these things stick in your throat. That's why I had Martian water here. Yeah, so that experiment is very controversial. I mean, I have friends who believe that actually they did find life. Some people think it was hydrogen peroxide. There's a downer that I glossed over real quickly, that there's perchlorates on the Martian soil.
That's what I was gonna ask.
It's we can't experiment. It's a hazmat substance, perchlorates. In humans, they cause thyroid problems and even cancer. So I told the students, I said, this isn't what you would have on Mars. You would have to get rid of the perchlorates. And it's anywhere from 0.1% to 1%. It probably is left over from the lakes that dried up the salts that were left behind. There are ways. We had an experiment that we had bacteria. There's perchlorates here too, because they use them in fireworks and fertilizer from birds and pigeon poop. So there's bacteria that do eat it. So we were suggesting to NASA that we could have an experiment with looking for bacteria that would eat because it happens on Earth, they'd eat the perchlorate and giving off oxygen. But I can't do that at Villanova because it's a hazmat material and I didn't want to go near there. I didn't want to have an extra worry. I was only worried about whether the plants were alive or not. And with the perchlorates, a whole different game. NASA is doing that.
His whole career, Gil complained that NASA wouldn't repeat that experiment. So why won't they repeat that experiment?
I don't know that because my friend believes that they did find life.
I had a question regarding
Why did they do that?
protein.
Protein. What is that? There you go.
Which I was kind of wondering that while you were going, I mean, wait a minute, we gotta have protein. You can't just eat one. Well, you can't.
Well, worms. Worms are protein.
Yes, when you brought that up, then I started thinking, what about plant life like soy? Soy, they did grow soy.
Yeah.
And I guess you could tell by how I do know.
Soy needs light. Soy, it needs a lot of sunlight. And we were growing things at 40%. When we put LED on soy, we got it to make soybeans. So you could, if a plant, like a tomato, will sprout, but it doesn't produce tomatoes, because there's not enough sun. So same thing with soy. Peas did it. I don't know why they did, but we got peas and we got little flour in the pea. We had to sell fertilizer. Soy would grow, but LEDs, we'll use LEDs for that. And that would be a source, a very good source of protein, rather than the worms. The worms you would probably have to process and make it into like a Soylent Green kind of thing to fool people.
Have you guys worked with composting
Yeah.
plants that you?
That's what we do. Yeah, the plants that die, which were, because your students, plants do die, they don't work. We put that into the worm farm and chew it up. So we wanted to have it clearer. The kids feed them. I mean, they just feed them pizza It isn't the way I wanted it, but it should be like a recycle. I was trying to make a cycle that would be self-sustaining. But the students threw other things in there to the worms, and the worms love it. The worms eat everything up. So worms come to the surface when the students come in.
I got a question from YouTube, from Mark Menser. Said, any attempts at genetic engineering plans for Mars?
Yeah, that would be cool. That would be the thing to do, to try to genetically engineer a plant for the environment. Still, the surface is nothing. Only thing that could exist there maybe is a tardigrade and spores in their down state. Tardigrade in the tune state maybe would survive. The surface is really cold and dry, and even if you go, we were thinking of Arctic plants, lichens and things of that sort. Still, it doesn't. There's nothing growing in Greenland, not Greenland, and Antarctica, and it's the closest match to Mars is Antarctica, without so much water ice. And yes, that's not, we can't do that, but they're thinking of that, genetically modifying plants, actually for shade and producing more protein. So it's cool. Yes.
When you supplement it with the LEDs, which color temperature did you use?
Solar.
So
We don't have to use that. That's what we used.
okay.
We had different choices, as you know.
So more like 5,000.
Yeah, 5,000. You can do 10. 10's better. Plants grow better in 10. He's talking about the color temperature of LEDs. You can adjust it to make it like the sun, which is 5,000 degrees, or 10. 10 is a bluish color. So this combination of different colors, you can adjust it. I should play with that more. I didn't do it. I just took the sun. Because I wanted to still try to have it sort of solar, but there's no need to do that. It would be a good experiment. We think that that's the way to go. I mean, the Martian soil, we found the hydroponics. The plants that were growing in hydroponics did 10 times better than anything growing in the Martian soil. And so that's what we have now. We have a hydroponic system that we got, and we can go big time. The lettuce that you buy in the stores, it's hydroponics. Your tomatoes are hydroponically grown. And that's what I think they'll do on Mars.
So
You have to think of the environment. You have to have humidity. So the greenhouse has to be humid. You have to have nitrogen in there. And so it's a lot of tricks you have to play.
So basically, the Mars thing is you got the Mars soil, but you're supplementing everything else that we would need
Yes.
to grow.
Yes. More soil, nothing. Things will sprout, but things won't grow. They'll grow like that high and die. Lettuce, you can get it. You can get a little bit of lettuce out of it.
How much water is gonna be required for hydroponics and where's it
A
gonna
lot.
come from?
Well, that's hopefully comes from Mars. Where NASA's planning to land is an area where there's supposed to be permafrost. So that's what you'd have to do, but unfortunately, it's probably salty water.
Yeah.
The water they saw, there was a spring that came up and it left a residue behind. Several of these have happened, like a geyser. The geyser wasn't seen, but the streak was. And they analyzed it, and it was highly alkaline salt. So you have to deal with that. The thing that worries me most are the perchlorates. I had to do an interview for The Martian, what was wrong, what was right. And I was talking about the wind and their hairs, that kind of stuff. And I thought about it where I said, no, if they would all die, The Martian would be a very sad story. He would have gotten, messing around with the soil, would have gotten a thyroid disease from the perchlorates, radiation also. And there's people who turned around and came back. They were 2 years in orbit, coming back to rescue him, all would have developed lung cancer. So it wasn't run. It was a downer story, but the radiation levels are pretty high. And he was not underground. If you go underground just a little bit, 6 inches, you're safe. But he wasn't. He was walking around the surface. And the people in the spaceship, there was no shielding. They didn't talk about shielding anyway. Maybe they had a spot. Even going to Mars is tricky. The radiation you get from the sun, from the X-rays and all that you get from the sun is pretty high. It's like you can only survive two trips. You have the life dose of radiation. Someone told me it's like getting 1,000 X-rays, chest X-rays in a day. And I think, it's pretty high.
We have a couple of questions over on this side.
Can't see, can you raise your hand? I'll go over there. I'm not using a mic. Can you hear me though?
No, you are using.
Oh, I am using. What? Okay, I'm good.
I was curious, with your success with dandelions, there's so many edible weeds.
Oh, yeah.
That are out there. Have you considered just exploring
We have.
plantains and?
People wrote to, it made the newspapers, so
Yeah.
people wrote to us with ideas.
Mhm.
Artichoke, what do they call it? Jerusalem artichokes.
Yeah.
Did well. Kristen wrote about trying them and various grains. Grains don't do well because of the light. Wheat needs, we had trouble with our barley because it grew, we got barley out of it, but it was trouble. We had to put LEDs on it to get enough for beer. So the light level. So once you give up on the light and go for shade plants. Actually, dandelions like light, so they did much better with outdoor LED than they did in what we did. One of the things we found out too is that there's no clouds on Mars. So when you actually add up the cumulative light, you're getting like 55%. When you take away dust storms, we have, even around here, it's very cloudy, but even in Arizona, you do have cloudy times. So we were counting that we could raise our light level up a little bit from 43% to 55. That would make everything work better. So, but we think LEDs and hydroponics is the way they're going to go. Although, it's not as, when I run the course, just growing things in lunar soil, Martian soil is much more appealing to a student, much more attractive. And it is to me too. Yeah.
If one of your problems is that there's only half as much sunlight,
Yeah.
couldn't you get and just put a large mirror behind each greenhouse to redouble it back to something approximating to terrestrial levels?
Yeah, you could do that. You weren't allowed to do that. You could have solar reflectors, but they have to.
You'd have to space the greenhouses further apart,
Yeah.
obviously. You've got the entire planet to play with.
Yeah, here, one of the sources of solar energy is not the photovoltaic cells, but these are greenhouse, they're focusing, they're like mirrors that focus like that would work. We never tried it, but it's theoretically should work.
Do you have any YouTube questions?
Yeah, one from YouTube from
Jeremy, let me know.
I need to get down there to, the person's here. Are they on?
on YouTube.
Am I in this, YouTube? So there,
Here's where the
I should
camera
go here. Hello.
Right, question from William Thiesing. Have they done any research on fungi such as mushrooms?
Yes, I had to. Mushrooms do very well. In fact, that was one of the ways we were trying to treat the soil, is to have mushrooms are just the flowers of the whole plant, and they work. So yes, the answer is yes to that, except I haven't gone in that direction. This isn't my research is not in this area. This is kind of a course I teach that has grown into, a different life. I spend too much time in the greenhouse. Yeah, I'm looking for exoplanets, life on other planets. And the Mars part, was just an experiment, a hobby and the New York Times got it. And all school children, I'm their mentor. So and one of the students introduced bacteria into the soil, which was really cool, more than we did. And mushrooms, there was a group in Texas. They won the prize. They won first prize in Texas for their science project. They had me listed at the bottom of their mentor, which I was happy about. It's better than our students.
They water the
They
plants.
didn't know how to water. But yeah, that's good. Yeah, mushrooms would be a way to go, because then you could use the worm manure. The Martian soil wouldn't be a thing. It would be growing it with the worms. That would be the way to go. There's no reason to use Martian soil for that. So you just use the worm feces, and the mushrooms would presume they did grow. I don't know whether every variety would grow, but I think it would be a good idea. And it wouldn't care about light. To grow them in the dark.
Any other questions?
Still have these worms in my throat.
Should we get you some more water?
No, I'm okay. I'll just chuck it down. I forgot that happened. Well, when students need 5 points, they'll do anything.
What's gonna power the LEDs?
Oh, I don't remember. We had 4 different kinds. They're commercial, I don't know what powers. No, I don't know the answer to that. You can look it up and send it to you. Yeah. We bought them online and they were like, $300 for the set.
What I'm getting at is where's the electricity gonna come
That's what I
from?
need, solar power.
Yeah, solar.
Yeah, but we didn't do it, we plugged them in, but you have to think that the students always lost that they're on Mars, and I keep telling them they're responsible for feeding, I would say their mother, their children, they wouldn't focus, and that's just the thing too, the LED requires power, that would involve bringing up solar cells and everything else, and they're light, but they're not that light. Yeah, so that's one of the problems. We didn't go there, but should have, to make it real. That you have to have a closed system. On Mars, you just can't send out for a pizza for the worms.
Likewise, if you eat the worms, you're in real trouble.
Well, I took, because of kids getting sick, I have to be careful. I fried them in olive oil. I had to drain the poop out. The same thing you do with, the process I use was very similar to you do with snails. So they put garlic, and then I fried them really hard. So there wasn't much, nutrients for there, but it wasn't the gooey, the fleshy part. But inside, some of them were like that. I mean, they had so much garlic salt. You couldn't taste it.
You're making that really appetizing.
They're Mexican. Yeah, there's the Russian. So that's a nice thing. That's the one I'm watching.
One last question I had was, if we ever get the Mars sample, if we ever get the Mars sample return samples back, it seems like the ideal experiment would be to follow up on Gil's experiment and say, will anything grow if I put the nutrients in that soil that I actually got from there? Because that would be the thing you want to grow there, if you've got a tremendous reservoir or whatever that might be, right?
Yeah, I think that the Viking could have protected.
I do too, actually.
I worked with an astrobiologist who does that kind of work, and he said, yeah, it's 2 out of 3 experiments, one indicated life, the other 2 didn't, and the answer was peroxide.
Yeah, I don't believe that.
That's
But
right.
anyway,
He doesn't either.
sports can live through almost anything.
But they had life died in the ocean. It wouldn't be much. See, a lot of people are looking for shells and fossils. It wouldn't have made it that far. Mars was like us for about 250 million years. And so what do we have? The algae, it would be that era. People are looking for like fossils of animals. That would be interesting. But I know one experiment there with one of the rovers, they're looking for fossils of shells. Yet, if you think of the Earth, 3.8, 3.7 billion years ago, the Mars habitability didn't last very long. So things couldn't evolve unless they went underground, unless they were living in a special environment in the permafrost, which could happen. But surface-wise, there's very little chance. And they're looking, it would be spores and not advanced, no skeletal remains. It just isn't.
I'd be excited about sports.
Yeah, so would I. Bad spores, but. Yeah, we there?
Any other questions?
I have a question about the wind and the effect. I have a question about the wind and the weather.
Yes.
And if that dust, are there dust storms that would block the sun from the greenhouse?
Oh, yes. Dust storms, it's the first sample I passed around, or I think I passed around this. This is, we can't work with this without masks. So this is very fine, and there's tornadoes on Mars, and dust devils. So at one point, the whole planet was enshrouded in dust. It was took about 6 months for it to settle down. But when that happens, you have to worry about, you're not getting much light in the greenhouse. We had like a backup that we could switch on LEDs if that happened. If the real thing, if you're on Mars, you have to have all these contingency plans. Not messing around and don't have a greenhouse where you can go outside and eat. But these duststorms do happen about every 10 years. They're kind of seasonal. And you can't see, when you're looking out from the outside, you can't see it in pictures. They completely get obliterated. It happened when one of the missions went up, it's a dust storm happened. Right when the mission was flying, and they had to wait for 6 months for it to settle. Yeah, so it gets along everything. So you have the greenhouse, you'd have to wipe it down. The greenhouse.
The solar panels.
Solar panels, yeah, would have to be clean. And how do you clean it? We can clean it with air, I guess, as long as it had filters. The perchlorates are the major thing that people forget about here, because they're bad news. And NASA is addressing that. They have a big experiment going on trying to how to get rid of the perchlorates or what to do with them. You can water that you can dilute them. And we saw bacteria that eat guano or perchlorates. They're used in fireworks and stuff like that. So, but it's not I'm not trained. It's too dangerous for the students. Yes.
What is the consistency of the soil? Would it be like talcum powder?
It's like this, more like this stuff. Not talcum powder, but granular. This is the closest match that, and I'll just say, it won't be, it's like this, like sand. Did you see this?
I did not.
Yeah, this is what the soil's more like, but there is this stuff, this dust that I showed you. I don't like working with that. Plants like it because they have an easier time getting through. As long as it's moist, if it dries, it's concrete. It's concrete. Yeah. So when you buy these things from the companies, they have different grades. The highest grade is the fine stuff because they have to do more work on it. And you can buy, this is medium and there's one that's coarse. Probably coarse is probably more what you would find there. So what I did with the top of that.
It's right on the chair.
Oh, thank you.
Another online question from Roy Patton, one of our returning champions. Says, instead of using the soil to grow plants, can it be used as food for bacteria to create an atmosphere in a hydroponic greenhouse?
Yeah, it's good. What's the name, Roy? Roy, good idea. It's been thought about. We can't go there, but yes. When you have a greenhouse on Mars, if you're growing plants, they need nitrogen and they need oxygen, a little bit of oxygen. Carbon dioxide is very plentiful on Mars, but humidity. If you don't have the humidity, which is water, they all, unless you have desert plants, they all die. Because we tried that game. We had an area, we blocked off an area and the humidity be very low. It's like 5%. And the plants did poorly, lettuce and things like that. And desert plants would be fine, but then desert plants need a lot of sun. So we were in a bind there. So yes, that's a great idea.
Yeah, one question of my own just occurred to
I
me.
hope NASA is not listening.
Where do you get nitrogen? You're saying you have on the earth.
Already there.
It's in the soil?
It's, well, it's 2% and 2. It's 95, I think I gave it like 95, 96% CO2, 2% nitrogen, and the rest other things. So
And that's enough to sustain agriculture?
We're not sure. That you need to probably increase that. Nitrogen is very important. You need nitrogen fixing bacteria. And you need nitrogen for that to take it out. And it's at the in the web of plants, it's down in the roots. So it's a whole system. And there's the high school kids where in Texas, they were called it's a candy. The Oreos, they were called. They tried that experiment and they were successful. So I sent their poster in from NASA and said, maybe look at this. And better than our students, they had really good ideas.
Yeah, nitrogen fixation is a big thing. Because if you have the elements and you have plenty of energy, you can do a lot of chemistry. But if you don't have the elements, there's not much you can
The
do.
nitrogen is there in the air, so it's, you know, it's not like us, that we're 78%. It's 2%, 3%, something like that. It's not enough, but it's there. They have plenty of CO2. The worrisome thing with the greenhouse is that you'd probably have to encapsulate, the plants would have to be put in the plastic or not styrofoam, but to keep the humidity. Because you couldn't have a greenhouse like at Villanova. Our greenhouse is like 70% relative humidity. You couldn't do that. Be too much water waste. So you would have to then bag the plants and keep it have a microclimate for them. That's that. You had a good idea. Probably. Anybody care for worms? Should have brought the worms up. Thank you.
Thank you very, very much.
Thanks.
I think
I'll
we'll have some people signing up for your course soon. Okay, well, that concludes our program for tonight, but you don't have to leave just yet. If you'd like to purchase any of the things we have over there, talk to Barry.
Galileo, so don't forget that.
Raise your hand, Barry. Talk to Barry about the Barlow, high quality Barlow. Talk to me if you'd like the Celestron power tank. And don't forget the free Barlow that you can have the case, you can have the tripod, you can have whatever you like out of that case over there. And don't forget about the book sale that Ken talked to you about. Okay, well, thanks everybody, and we hope to see you soon at our next activity.
I just wanted to say thank you so much for letting me present. I had a lot of fun preparing that.
Yeah, you did a great job with your prep.